In today's activity, we're going to use what we know about laws of conservation, balancing equations, moles, and we will put those together to figure out the empirical formula and the percent composition of a chemical compound. So what we're going to do is we're going to take some magnesium, which I have right here. You can see it's a nice, shiny or lustrous, malleable metal, and I've kind of rolled it up into a loose ball to fit into a crucible. This was way back when we did the equipment lab video, which I'm sure you've all watched multiple times. We're going to heat it in air. It'll react with oxygen, and it'll make magnesium oxide. So if we know the mass of the magnesium, which we will, and we know the mass of the magnesium oxide, we can figure out how many grams of oxygen are in this compound by applying the law of conservation of matter. And if we know the number of grams of magnesium and the number of grams of oxygen, we'll be able to figure out the moles of each, and then we'll be able to figure out the ratio or the empirical formula and see if in fact it is 1-to-1. So the first thing I'm going to do is I've set up my ring stand with the clay triangle. I'm going to turn on my balance, and I'm going to weigh an empty crucible and its lid. Oops. Here we go. And they weigh 22.29 grams. And I'm purposely not handling this with my fingers, partly because if it had come off the burner, I may or may not know if it's really hot, but also because I don't want moisture from my skin to get on here and change the weight. Now I'm going to add my magnesium. So that was 22.29. I'm going to add my magnesium metal, put the lid back on, and weigh it again. So we've got the mass of the crucible and lid. We've got the mass of the crucible, lid, and magnesium. And the difference in that, which you can figure out, and we will later, will be the mass of the magnesium. Now I'm going to take my crucible. I'm going to rest the lid at a little bit of an angle. So I want to let air in so we can get the oxygen to react. So I don't want the lid tight, but I also want it covering partly because I don't want anything to escape, because then I'd be losing some mass. So now I'm going to light my burner, and I'm going to place it under here, and it'll take a couple minutes to go. So you can see there's a little bit of a glow in there, and that's the reaction starting to happen. You can also see it's beginning to get a little ashy white. So we're beginning to convert the magnesium metal into magnesium oxide. And this will take a few minutes. So you can actually see, there you go. So what we don't want to happen is to have too much of the magnesium oxide escape, because then we won't be able to obtain its mass. So that's going to take a couple more minutes. And when it's all done, we'll take a look at the final product and we'll weigh it. Here we go. Getting close. Yeah. We have our magnesium oxide in the crucible with the lid, and it weighs 23.03 grams, which I've already written down. And you can see in here, the magnesium oxide is a white powder.
One moment. Tip it a little more. There we go. Thank you.
And we can compare that to magnesium metal. So we had several indications that a chemical change took place. We saw light being given off. We saw a pretty impressive chemical color change. So that's a good example. And one thing you might have noticed was there were little white sparks coming out, and that might remind you of something you see in fireworks. because magnesium is often used to give those nice white flashes. Okay. We're going to just transfer our data up here. So the crucible and lid was 22.29 grams. The crucible and lid with the magnesium was 22.74 grams, which means the magnesium alone was 0.45 grams. The final product with the crucible and lid was 23.03 grams. I'm just taking the crucible and lid from up above, which was 22.29 grams, so the mass of the magnesium oxide is 0.74 grams. So we can kind of use the law of conservation of mass and say 0.74 grams of MgO minus 0.45 grams of Mg is 0.29 grams of oxygen in that final product.
Go.
So now we're going to take our data and figure out the empirical formula. So we've got 0.45 grams of magnesium, 0.29 grams of oxygen. We're going to convert those into moles. Now, depending on how you've seen things in class, you may have used dimensional analysis, or you may have used a mole diagram. But either way, you're going to end up with 0.0185 moles of magnesium. Okay? Make sure you punch that in and get that answer, because in a minute, you're going to get your own data and be on your own. For the moles of oxygen, 0.29 grams of oxygen, 1 mole is 16.0 grams, 0.0181 moles. So the ratio of those two, 0.0185 divided by 0.081, 0.0181, that, is almost exactly 1 to 1. And if you look at the formula of magnesium oxide, it is MgO. If we had done this where the formula was a 2 to 1 ratio, we would have seen that in the final ratio. So now you're going to get your own data and work through similar calculations, and make sure when you do it, pay attention to units, use your sig fig rules, and you should be good. Thank you.